Yeah, get it for Brandon. All right, so for 5-6 today, we are solving by completing the square. All right, so um, the objective is to solve quadratic equations by completing the square, and it's a method that can be used to solve any quadratic equation. Okay, that's kind of new. We haven't been able to do that. The strategies we've learned so far haven't been able to do that. So we're, again, solving a trinomial or quadratic equation um, and just learning more and more ways to do that. So equations in which the left side is a perfect square trinomial can also be solved by taking roots. Right? We haven't done this lesson yet, have we? Okay, because the other one I was like, the problem we just did was kind of like that. So if we look at this first example, we have solve x squared minus 8x plus 16 equals 49. So it says rewrite the perfect square trinomial as a binomial squared, which is actually what we just did in the previous problem. It was a little simpler, okay? But we have the x squared is a square and the 16 is a perfect square, okay? So then the factors of 16 that would get us 8 are -4 and -4. You got it. So that's where we get this x minus 4 squared. So the book shows it this way. I don't necessarily think that's a very helpful way, but I put it in there. So like it's would look like this initially, and then we could change, because it's the same, like we just did, we can write it as x minus 4 squared, okay? And then we solve by taking roots. So what that means, we have this x minus 4 squared equals 49. So now we're going to take the square root of that, which you all could show it higher up. So the square root of the first one is going to be x minus 4. And what's the square root of 49? 7. So we've got plus or minus 7. Then we'd need to add 4 to get the x isolated. So x would be 4 plus or minus 7. You should write this down. Good call. And so then what would our x values be? So
it would be
11 or -3. So what we're doing is 4 plus 7 and 4 minus 7. Well, and I wrote the -3. Good job. Geez, I'm going to do it again. Okay, so the 4 plus 7 is the 11, and the 4 minus 7 is -3. So our x equals -3, comma 7. Can be either one of those. 11? Oh my goodness. Yikes. -3 or 11. Apparently my brain is not functioning today.
Okay, how, the 16, what did you do with that? How did you?
The 16, we just broke it into a binomial, right? Because 4 times 4 would equal 6. Actually, -4 times -4 would equal 16. And -4 plus -4 would equal the -8.
Okay, that's
Mm-hmm.
that's when we used the last number. Okay.
Yes.
Yeah, I was like, how did you
Yep.
get rid of the 16 and the 8?
Yes, and that's why. And so because these are the same factor, that's why we can solve by taking roots.
Okay,
Mm-hmm.
that makes more sense.
If they were two different numbers, we couldn't use this strategy.
Okay, so I need to remember that. I need to circle that and that.
Okay.
Remember.
Now, like I said, these two numbers have to be the same in order for us to do this. If not, then we wouldn't be able to use a strategy. However, I also said this can be used to solve any quadratic. So how does that work out? You can solve it to solve any quadratic, but it has to be a perfect square. Yeah, right? Magic. Okay, so this is where The fun begins. You got it. So every quadratic can be changed into an equation where one side is a perfect square trinomial using a process called completing the square. So to complete the square of an expression in the form of x squared plus bx, okay, we're going to add, not the best color to use, perhaps, add the square of half the coefficient of the linear term. Like, what are we talking about? Okay, that's, okay, so we're going to do half, so that's why we have it divided by 2, or square of, so that's why it's squared, of the coefficient of the linear term. B is the linear term, okay, because it's the quantity that's being multiplied by x, so that's what that is. So the square of half the coefficient of the linear term is simply b over 2 squared.
Why do you do that?
Because it's going to make it a perfect square.
Oh, so that's only when it's not a perfect
It's
square.
only when it's not a perfect square.
Okay, because I was like, if you take 4 divided by 2,
Mm-hmm.
that's 2. But if you then square, it's 4 again, and you've gone nowhere.
Right. So let's look at example 2. We'll give it a whirl here. So for each expression, complete the square and factor the resulting trinomial. So here's where we're starting. X squared minus 6x. Okay, so we want to add the square of half the coefficient of the linear term, that whole thing here. So that's the b. Our b is negative 6. So we do negative 6 divided by 2 squared. Okay, so negative 6 divided by 2 is negative 3. And then negative 3 squared is 9. So here we go, we're at 9. Now we have a perfect square, trinomial. Yeah, you leave the negative 6 there, nothing else changes. We're just adding a third term to make it a perfect square.
And then you do negative 3
Yep,
times
because,
negative 3, which added is negative 6.
right, negative 3 times negative 3 would give us a positive 9, and then negative 3 plus negative 3 would give us that negative 6 that we're looking for. So there we would have it. It's the x minus 3 squared. We're just practicing that skill at the moment. Okay, so this is that first step. So let's try this other one, because we've got a fraction, so that's a little harder. Okay, so
Is there a way we could make that a whole number? Wait.
I know what we can do.
you could, but it has to be in, you want it to be x squared, in this form x squared. I see what you're saying. It'd be nice to make this not a fraction, but we don't have an a value in front of x. It has to be x squared or y squared with no a value. Good call.
So if there is an a value,
We'll deal with that another time.
okay.
Okay. All right, so right now we're going to do step 1. Add the square of half the coefficient, so half of the b term. So what is b?
5
Okay, so we're going to do 5/3 divided by 2 squared. All right, so let's think. Oh, you could do calculator, but I mean 5/3.
Also multiply it by 1/2.
You could multiply by 1/2, right? Multiply that reciprocal. So that would be 5/6, and then we square that. So times 5/6 would be
25/36.
25/36. You got it. Yes, ma'am. Yes. Okay. So it'd be 25/36. So let's see. We'd have y squared plus 5/3 y plus 25/36. Now, I will tell you, sometimes, and this is one of those cases, it's actually easier. Don't write anything yet. I want you to watch. Just a second. So this part is the same thing as 5/6 squared, right? Which is equal to the 25/36. Which we're going to, because this is a square, we're going to take it back down to the square in the next step to get this squared term. So we're going to have y squared plus or minus, plus, or sorry, not y squared. It's going to be y because we're taking it to the next step. If my eraser would work. There it goes. So it's going to be y plus 5 sixths squared anyway.
Okay.
Right? Because when we do this, like when we got the 9, we still had to go back and find the square. We had to find the square root of 9. So my point is, you don't always have to do this math. We could have left it as 5 sixths, like y squared plus 5 thirds y plus 5 sixths squared. Because just like when we take the y, it's y squared, we take the square root. Well, that's just y plus the 5 sixths. And then square that binomial. So I'm just saying, you don't always have to do this math to get this number, especially if it's a fraction. You can just write it as, oh, that's just going to be 5 sixths squared. Because you're going to have to take it, find the square root of it anyway. And then you get to keep it. Okay. All right. Let's clear the page. So let's see. Remember, if you add a number to one side of an equation, so we were working on expressions. Now we're talking about equations. So if you add a number to one side of an equation, you must add it to the other side. So now, example 3, we're looking at an equation and not just an expression, which is what we had before. Okay? So it says solve x squared plus 10x equals 15 by completing the square. State the roots as both simplified radical expressions and decimals. So again, kind of talking back to what our questions were earlier. If it asks you for a decimal, you're using your calculator to put it in. Okay. All right, so the steps again to solving the quadratic equation by completing the square. Step 1, write the equation in the form x squared plus bx equals c. Is our equation already in that form?
Yes.
Yeah, right? We have nothing in front of our x. We've got b is our 10, c is equal to 15. So we're going to start there. X squared plus 10x equals 15. Okay, step 2. Complete the square by adding b divided by 2 squared to both sides. Okay, because it is that equation. Okay, so we're going to, first of all, just do x squared plus 10x, and then plus, what's our b? 10. So it's 10 divided by 2 squared. And we have to add that to both sides. So that's going to equal 15 plus the quantity, 10 divided by 2 squared.
Which is 25.
Okay, so I like it, you're ahead of it. So let's simplify that. So then we have x squared plus 10x. If we simplify, 10 divided by 2 is 5. 5 squared is 25. So 15 plus 25 is,
30, 40.
all right, is 40. Good. Okay.
That's something funny. Jax, my 6-year-old brother was asking me what math I was working on in school because he's in kindergarten and started working on math or
Uh-huh.
whatever. And I was like, well, I'm working with perfect squares, and he was like, perfect square? What's that? And I said, well, it's when a number times itself equals something, and that something is a perfect square.
Uh-huh.
And he goes, oh, so 25 is a perfect square because 25 is 5 sets of 5.
And you're like, you're a smart kindergartner.
I looked at him, I was like, you're a punk.
You should say, you are so smart. Okay, so let's look at step 3.
Look at him was like, how do you know that?
Factor, we want to factor that perfect square trinomial. So that's when we're looking at, okay, we've got this perfect square here at the beginning, the perfect square at the end. So what are the factors of 25 that get us 10? 5. And it's going to be positive or negative? So x plus 5, that quantity squared, equals 40. Because again, this is, I'm going to write it out, the same thing as x plus 5 times x plus 5. You can skip that step and just write, well, it's x plus 5 squared. And that last step then is solve by taking roots.
So we square root the whole thing.
We square root the whole thing. So we're going to have then x plus 5 equals plus or minus, and now is when we need to simplify that 40, what the square root of 40 is. So 40,
divided by 2 is 20.
good.
Divided by 2 is 10. Divided by 2 is 5. So there's a set of 2 and then a 2 and a 5.
Okay, so there's a set of 2 we can bring out, and then the 2 and the 5 have to stay under. So what is 2 times 5? 10. 2 times the square root of 10. Okay, and so then how do we finish solving it and isolate the x?
5 and, subtract 5, I'm sorry.
That's okay, subtract 5.
And x equals negative 5 plus or minus with 2 times the square root of 10.
Good, plus or minus. I forgot my 2. Again, if my eraser would work today. There it goes. Plus or minus 2 times the square root of 10. And like when it's in that form, you're done. Like you can leave it there, except it does say, because that's our simplified radical expression. Okay, if you put it in the calculator, which, I mean, you guys can put it in the calculator anytime, but it'd be like 1.32 and negative 11.32.
And it doesn't want us to find that?
It does, but we'll save the time, because I know you guys know how to put it in a calculator. Yeah, so we'll save the time while we're going on notes so you have more time to work on it. So how do you feel about that?
So far, I feel okay.
Okay. It is just that like b divided by 2 squared concept. That's like, what? But you're always getting, it's nice that you always get a perfect square. Like you know that's what you should get every time. Okay, so then let's look at example 4 here. All right, so earlier you asked, well, what do we do when we have a number in front of our x? Okay, so there's a couple of flaws or hiccups in this problem. The other one is that we don't have, so we're supposed to have x squared plus bx equals c. Well, it's over here. That constant, the c is the constant, it's on the left side. So one, we have to move that to the other side, so we add 10. And then we have to do the dividing by 3 to get rid of this. We divide the whole equation by 3 because that's we have divide each side by 3, right? If we do it to one side, we do it to the other. So I just drew one big line. But that ends up getting us to this step, which is the x squared minus 13 thirds x equals 10 thirds. So now we have it in the right form. And then we can solve. So let's take this step on b. Let's deal with b first before we actually solve. Because it's the solving part I'm not really concerned about. So let's go ahead and look at b. Because we've got 5x squared. That's our problem. And minus 10x plus 9 equals 0. So the 9, we've got to subtract 9 to get it to the other side. Good. Good. Yes, so you can do two different things, like divide this side by 5 and this side, but the longer math I have to do, I usually just draw one big line and divide the whole thing by 5 to show it. Okay, so we have x squared minus, what's 10 divided by 5? Ah, 2x, it's a nice number, equals negative 9/5. Okay, perfect. All right, so now let's go ahead and solve it. We took care of that part. Now we've got our standard form here that we have to have. So now let's take it to the next step. We're going to add the b divided by 2 squared. So x squared minus 2x plus the quantity. What's our b?
2x.
Not 2.
Negative 2.
Negative 2, right? Don't forget that it's a negative 2. So negative 2 divided by 2 squared, okay, equals, no, 9/5 times. Oh, sorry, yeah, plus. plus.
-1 squared is 1.
Okay, so then we've got x squared minus 2x. You guys are fast. Plus negative 2 over 2, you said is negative 1. Negative 1 squared is 1. Awesome, perfect. So what's negative 9/5 plus 1? So that, remember, negative 9/5 plus 5/5.
Yeah, it would be -4/5.
Negative 4/5. Okay. All right. All right. So we've got this. Now we're ready to factor it. Okay, and get that. So we're looking at the x squared
That's not a perfect square.
and the 1. It's not?
I mean, you could have -1 times -1, but it's not really.
That's it. It's negative 1 times negative 1.
But I don't like that.
You don't you don't like that. 1 is 1 that it's easy to not like. Okay. But it is going to be x minus 1 because negative 1 times negative 1 is a positive 1, and negative 1 plus negative 1 equals a negative 2. So it is work. So then that equals negative 4/5. What do we do next? Take the square root. You're good. So then we have x minus 1 equals plus or minus the square root of negative 4/5. Okay. You guys are doing awesome. Plus 1. Okay, plus 1. So x equals 1 plus or minus the square root of negative 4/5. We need to simplify that radical.
So it'd be I.
We'd need an I. Okay. Now the other thing too with this, right? This is the same thing as the square root of negative 4 over the square root of 5.
Okay.
So
Okay, yeah, so we
can we
maybe have that.
times it by
The square root of 5 on both sides.
Wait.
5 negative.
What
I'm
if
sorry.
we
Square root of 5 over square root of 5.
Okay.
That's what we multiply by.
Okay. But also
can
we.
take the negative 4
Uh-huh.
and change it to 4i and then multiply it by square root of 5?
But
First,
you-
the square root of.
But you also know the square root of
is
4.
2.
The square root of 4 is 2. So the negative, yes, so you're on the right track. So I'm going to draw a line here we're going to pick up. So this is going to be x equals 1 plus or minus 2, because the square root of 4 is 2. The negative is the I over a square root of 5. We're not quite done yet because what's the rule about simplifying radicals?
Can't have one in the I.
You have to have a whole number denominator. So earlier somebody said, okay, we'll multiply this by the square root of 5 over the square root of 5. So now we're going to have x equals 1 plus or minus what?
2i times the square root of 5
Yep.
over 5.
Over, yeah, 5.
Woo! You all did masterfully on that. That's a problem like that combines all the things that you've learned in like the past 5 lessons, right? Like
I don't
understandable, but it is kind of a nice conclusion to the lesson. Like, man, we've learned this and this and this and this, and like this just pulls it all together.
And when I looked at that, I'm glad I've already passed algebra 2.
Mm.
I don't want to do that again.
Yeah, but you're in geometry.
But you guys did wonderfully with that. So nice work.